Okay, so least and greatest values. Now remember that when we're rounding numbers, if the number, we always look to see if the next decimal place down, or the next place down that we're rounding to is 5 or above or below. So if we were rounding a number to 9 and we were rounding it to 1 decimal place, to 0 decimal places, we would first of all look at the decimal place below. So in this case we would be looking at the first decimal place because we're rounding it to 0 decimal places, and we have to see whether that is 0.5 or above, and whether it's 5 or above. If it's 5 or above, then the number is going to go up. If it's below 5, then the number is going to go down. So for example, if I looked at 9.6, rounding to 0 decimal places, I look at the first decimal place. Is it 5 or above? Yes, it is. So the number gets rounded up. We add 1 on to the 9 and I can forget about everything else. If I looked at 9.2 to 0 decimal places, we look at the first decimal place because it's always the next decimal place along that we check. Is it 5 or above? No, it's not. So we just chop off the decimal and put it to 9. So let's have a look at some examples. So rounding these to 0 decimal places, 5.8 first of all, 0 decimal places, so I look at the first decimal place. It's 5 or above, yes, so we add 1 onto the 5 and take away the decimal place. 8.3, 0 decimal places, we look at the first decimal place. Is it 5 or above? No, so we just chop off any decimals. 7.6, to 0 decimal places, so we look at the first decimal place. Is it 5 or above? Yes, so therefore we add 1 onto the 7 and get rid of the decimals. 8.2, we look at the first decimal place. Is it 5 or above? No, so we just chop it off. And then 9 to 0 decimal places, we look at the first decimal place. And is it 5 or above? No, so we chop it off to give us 9. Now remember, we can also round numbers to 1 decimal places or 2 decimal places. So let's have some look at some other examples. Let's first of all round 6.23 to 1 decimal place. So I'm rounding to 1 decimal place this time, not to 0 decimal places. So I don't look at the first decimal place, I look at the next decimal place down, the second decimal place. But I then follow the same procedure. Is it 5 or above? No. So we chop off from that point onwards, and I'm left with 6.2. With the next number then, 7.95, we're going to round it to 1 decimal place, not 0. So we don't look at the first decimal place, we look at the next decimal place. And is it 5 or above? Yes, so we have to add 1 on to the decimal place above. And as it's 9, the 1 gets shifted over and added onto the 8. Now if you look what I've done there, because it's rounded to 1 decimal place, I have to show the first decimal place. So even though it's 0, and that would normally be hidden away, we leave it there to show that we've rounded it to the 1 decimal place. With the next two, we'll round them to 2 decimal places. So if I'm rounded to 2 decimal places, I look at the 3rd decimal place. So with the first one, it's not 5 or above, so we chop off from the 3rd onwards. And with the last one, the 3rd decimal place again, because we rounded to 2 decimal places, is a 5, so we add 1 on. So we get 9.65 instead of 9.64. So look at the next decimal place down. If it's a 5 or above, add 1 on to the previous decimal place and chop off the rest. If it's below 5, just chop off the rest. Now, rounding becomes particularly important when you're using the least and the greatest and working out the least and the greatest. For instance, I was doing DIY the other day, and a plank was supposed to be a foot long in the measurements, and it didn't fit in the space I needed. And when I went back to the store, he told me that it was actually a foot to the nearest half an inch. So there's a range of sizes that can be. A foot is 12 inches, as you'll have to know for your unit conversions. So if I've got 12 inches and it's to the nearest half an inch, so I want to look at the first decimal place, and let's say for instance it was 12.4. Now remember, we're not rounding to 1 decimal place, we're not rounding to 0 decimal places, we're rounding to the nearest inch this time. So nearest half an inch, sorry. So half an inch would be 0.5. So we're looking, do we go up to 0.5 or do we go down? In the case of 12.4, 4 is closer to 5, so we round up to 12.5. And you can see there from that example that the plank, which is supposed to be 12 inches, is actually 12.5. Fortunately, some of them are easier, most of them are easier than that in the exam. For instance, you're usually told that maybe a tile is 5 inches long to the nearest inch. So what that tells us is we have to look at the minimum and the greatest that it could have been before it was, when it was rounded down. So for instance, if it was 5.1 and it was rounded to the nearest inch, that means we'd go down to 5. 5.2 would also go down to 5. 5.3 would go down to 5. 5.4. But now remember 5.5, the rule was that if the decimal was 5 or above, then we'd go upwards instead of down to 5. So the maximum size that tile can be is 5.4 inches, because 5.4 or less, it would get rounded down to 5. So if you noticed, what I did was I added 0.4 on. When we're rounding to 0 decimal places, we add 0.4. If we're rounding to 1 decimal place, we add 0.04. If we're looking for the greatest for 3 decimal places, it's 0.004, and so on. Similarly, we can go in the other direction, where we've got 4.9, 4.8, etc., all the way down to 4.5. Now, when we go past 4.5, 4.4 would actually get rounded down to 4. So the plank couldn't be 4.4 inches long. So the minimum length that it can be is 4.5. That plank, sorry, I've gone from tiles to planks. That tile could be anything between 4.5 and 5.4. And if you notice this time what I've done is I've deducted 0.5 to find the minimum length that it could be. If it had been to one decimal place, remember that it would be deducting 0.05. to 2 decimal places, 0.005, and so on. Now there's two main ways in which that they put these questions to you in the exam. One, for instance, is to give you, well, three main ways really, just to ask you the least and greatest of a particular value, and that's fairly straightforward. You just do the add in the 0.4, the 0.04, the 0.004 on, or take in the 0.5, 0.05, 0.005 away. Another one is where they give you a series of minimums or greatest lengths, and you have to work out the overall size. So for instance, if they give you a table of length 8 feet and width of 2 feet, and they ask you for the perimeter of the table if it's to the nearest foot. Well, and they ask, say, what is the minimum it can be? Well, we know that the perimeter of a rectangle is twice the width and twice the length. So if they had just been 8 and 2 and they hadn't said to the nearest, it would be easy enough. 8 plus 8 is 16, and then add the two 2's will give us 20. The length of it is 20. But they've said to the nearest. Now if they wanted the least, we have to find the least of both the width and the length. So to find the least, we deduct the 0.5 off because it's to 0 decimal places, giving us a least length of 7.5 and a least width of 1.5. So instead of adding the whole width on twice and the whole width on length on twice, we take our minimum lengths twice and our minimum widths twice, and we add those together. The other way in which they might give you a question is for you to prove that a certain value can be met. One exam question I saw on this was if a bag of sugar weighs 500 grams to the nearest gram, we need to have 2,498 grams. How do we prove that we've got that amount if we've got 5 bags? Now, if we had the 500 that we've been given, then it'd be easy enough, because 5 times 500 is 2,500. But we don't necessarily have that value. We could have the minimum value for all those bags. So the only way we can be sure that we have the required value is that should all of them be of the minimum value, it still comes to over 2,498. So let's find out what the minimum value is. If it's to the nearest gram, we look at the next decimal place down, and we deduct the 0.5, giving us 499.5. That's the minimum value that it can be. There's 5 bags, so if all these 5 bags were their minimum size, that tells us that it would come to 2,497.5 grams, which is lower than the required amount, and therefore we cannot be sure that we have the right amount of sugar.